In number 31, which of the following rules can be used to determine the magnetic field direction about a straight current carrying conductor? A. The corkscrew rule. Yes, it is the corkscrew rule. You can also use the right hand grip rule to determine the direction of the magnetic field around a straight conductor that is carrying current. The other rules are used like the Fleming's left hand rule and the Fleming's right hand rule. They are used to determine either the force or the direction of the induced EMF when a current carrying conductor finds itself in a magnetic field. In number 32, a material that is easily magnetized and easily demagnetized is referred to as an electromagnet, a hard magnetic material, a soft magnetic material. C. Soft magnetic material. Number 33. A transformer is used to operate a 24-volt radio from a 240-volt mains supply. Which of the following statements is true? A. The input current in the transformer is direct. No. Transformers only function with alternating current and never direct current. B. The transformer has more turns in the secondary than in the primary. The first thing is that the number of turns is always directly proportional to the voltage. And here we can see that the mains supply, the mains voltage is 240 volts, and this is usually the primary. While at the output, we have 24 volts, which are being taken by the radio, and this is usually the secondary. Now, when you look at the voltages, the primary voltage is 240 volts, and the secondary voltage is 24 volts. So there is a drop in voltage from the primary to the secondary. So we also expect, due to the direct proportionality between voltage and the number of turns, that there should also be a drop in the number of turns from the primary to the secondary. The statement in B says the transformer has more turns in the secondary than in the primary. So that statement is wrong because the number of turns in the primary should be more than in the secondary, since the voltage in the primary is also more than in the secondary. C. The transformer is a step-down transformer. Yes, the voltage in the primary is 240, while in the secondary it is 24. So there is a drop. Voltage has been stepped down. So this transformer is a step-down transformer. In D, the turns ratio secondary is to primary is 10:1. This is showing that there are more turns in the secondary than in the primary, which of course is not correct. In number 34, isotopes of the same element have different numbers of electrons, protons, ions, neutrons. Neutrons are in fact the subatomic particles that are responsible for the phenomenon of isotopy. In number 35, two nuclear radiations, X and Z, are passed through an electric field as shown in figure 4. Now we have an electric field where there are positive and negative plates. The radiation that is positive, the one that is positive, will be deflected towards the negative plate, while the one that is negative will be deflected towards the positive plate. We have three main types of radiations: the alpha particle, the beta particle, and then the gamma rays. Now the alpha particles are positively charged, while the beta particles are negatively charged. And so the one that is deflected towards the negative plate of the electric field should be the alpha. So Z corresponds to alpha, while X corresponds to beta. So X is beta, Z is alpha, corresponding to option C. In number 36, radium-226 decays to a daughter nuclide by the emission of two beta particles according to the following equation. So we have the equation given, and normally we are asked to calculate Z, Z being the atomic number of the daughter nuclide. To calculate the unknown atomic number, we have to make use of conservation of charges by considering the atomic numbers only. And so we have for the parent nuclide, which is radium, the atomic number is 88, and it should be equal to the atomic number of the daughter nuclide, which is Z, plus two negative charges from the two beta particles that have been emitted. And so we have 88 equals Z minus 2, so that Z equals 88 plus 2 giving 90. So the atomic number of the daughter nuclide is 90, corresponding to C. In number 37, which of the following statements about gamma rays is correct? They carry a negative charge. No, they are not charged. They are deflected by electric fields. No, they are radiations rather than particles, so they will never be deflected. C, they are the least penetrating. No, they are instead the most penetrating. D, they are not deflected by magnetic fields. Yes, since they are radiations, they are never deflected by magnetic and electric fields. In number 38, which of the graphs in figure 5 best shows the relationship between the activity Y of a radioactive substance and the time of decay X? So generally, radioactivity is a decay process, meaning that the amount of substance or the activity of the substance usually decreases rapidly with time from a particular original value. And so option A is the best. B could have been considered, but the fact that the graph doesn't start from the vertical axis disqualifies it. In number 39, a student stands 10.0 cm in front of a plane mirror and sees his image in the mirror. How far is he from his image? So if this is the mirror, the boy is here 10 centimeters from the mirror. The image would be the same distance behind the mirror, 10 centimeters. We are looking at how far is he from his image. So we double the distance in front of the mirror. It means that he is 20 centimeters from his image, 2 times 10. In number 40, the image formed by a convex lens used as a magnifying glass is A. Upright, real, and larger than the object. No. B. Upright, real, and smaller than the object. No. C. Upright, virtual, and larger than the object. Yes. C. In fact, this is the only situation where a converging lens would form an upright image and also an image that is virtual. And this usually occurs when the object is placed between F and the optical center of the lens. In number 41, a ray of light is reflected by a mirror as shown in figure 6. And the angle of reflection is, so this angle 40 degrees is neither the angle of reflection nor the angle of incidence. The angle of incidence is this one between the incident ray and the normal, while the angle of reflection is the one between the reflected ray and the normal. And the 40 degrees made between the incident ray and the mirror surface is complementary to the angle of incidence. So 40 plus that angle of incidence should make 90 degrees, so that the angle of incidence would be equal to 50 degrees. And according to the laws of reflection, the angle of incidence and the angle of reflection are always equal. So the angle of reflection is 50 degrees, corresponding to option B.